Hello everyone, welcome back to the channel again. This is you are watching Beam Basics and Beyond. Myself, Amrit Kumar Tripathi, as you know, guys. And I know it's been a while. I haven't uploaded any videos in this channel, right? But in today's video, or I can say this is going to be a normal offline uploaded video, but it will be could be little bit on the longer side, but make sure you stay in this video till the end, and cause in today's video we are going to discuss about a very important engineering part in ELV design, extra low voltage systems called access control system. We will be learning in today's video. We will try to understand the system, how the system works actually, and everything about it, the architecture diagram, the servers, the connections, the we will understood how the system actually functions, right? So make sure that you stay in this video at the till the end, and I can assure you this video is it will be very helpful for you guys, because I am doing access control since I believe 1.5 year 1.5 years, and I totally from last 1.5 years I totally worked on the ELV system, work with ELV systems, especially LSS life safety systems. And if you know, and if you don't know, I want to say you that access control system is one of the most critical and most important system in the life safety systems. Under the life safety systems, access control system is a very important service, right? And these overall systems are in the, of course, ELV category, which is if you see if you tells about AC under 50 volt AC, and if you talk about DC under 110 volt DC, the ELV systems works generally. So let's start with access control system. So first of all, if you didn't, if you are first comer at my channel, if you are viewing my videos for the first time, make sure you subscribe the channel, because in this channel I uploaded videos about BIM, about electrical engineering, about electrical design. Although the name of the channel is BIM Basics and Beyond, but the channel will be dedicated for and is dedicated for BIM plus, of course, the core electrical engineering. So, okay, let's start with our topic. Don't waste much time. Access control system. So, what is access control system? So, this is the PDF I made. This is the Word file. This is the file I made, right? So, before go through this PDF, right? Whatever I will be talking about is in the PDF also, but beside this PDF, I will be explaining each and every concept to you orally. So, what is access control system? So, friends, access control system is not a very new, nothing is a new about, not a very new technology. It's, it's all, it's kind of old, you know. The access control system is always there in our, you know, door locking, and for security purpose, we have been using access control system for a while. But in today's generation, the system is much more advanced. It's getting advanced day by day, and it's now very secure. And it's a common necessity of today's building, and always recommended by various building and electronics code. To start access control system, we first start with for example, I will give you a concept about what project I am doing right now. It's a very critical and very security sensitive project. I will not name the project, but it's going to be one of the massive infrastructure in going to be in, become in near future in India's history. So, access control system, to design access control system, we first the scratch we start from the architectural layout. We borrow some layouts. Okay, we borrowed some layouts From the architecture team, for the architecture team, just make sure this is going on right. Yeah. So we first borrow the the layouts, the CAD layouts, the PDF layouts, whatever this is, the 2D layouts from the architecture team, because they to ensure to see to visualize the egress and the memo paths of that building or of that room or of that space, whatever it is, right? So we need to first check the egress layout, how the people will move, how the man and material will be moved through the place, from, for example, through the corridors, through the, doors, through the, roadway, the corridors, this kind of thing. We need to check how the material will move, how the people will move, how the people will go, how the people will came, how the people will enter the room, how the people will on the case in case of emergency, how they will came out from the space. So this everything we need to check, and we do check it from the architectural egress layout. The term is sometimes we call it egress layout, sometimes we call it memo path. So memo path is nothing but the path which is used for man and materials movement. For example, there is a substations, right? There is indoor substations, right? So that indoor substation could be, used for that corridor is could be used for the, uh, to move the heavy transformers, HV panels, maybe main DBs, some kind of distribution boards, switch gears, everything will be there, right? So we need to pass those through the corridors, then the room. So these are called MIMO paths. Okay. So this is how we check, and we got an idea about how the people will be flow, or the material will be flow inside that building. Secondly, we define types. We define, I have made some notes also here. We define, yes, we define types. Although we define types, types means, for example, there are varieties of doors, right, in the market, and we do use varieties kind of doors. For example, single leaf doors, right? As you can see in here, there's a single leaf door, right? That is there. We also use double leaf doors, two leaves open. Uh, you know, two leaves are there. Also, we use some shutters, some overhead coils, coil doors, usually used in shops, garages, uh, you know. So varieties type of doors are there, right? So by the doors also we define types, and later we adds the devices as per the door, and as per the door is supposed to do, and the door purpose. So let's check the devices part more thoroughly. So as you can see, assigning devices as per door type. So whatever we did till now, we have an idea about the egress path. We have an idea about, we see the MIMO and egress path. We defined the door. We define the door types. We see the door types, how what kind of doors we are having in our project. Now we will assign devices to our according to our door type, right? So for example, there are varieties kind of devices we use. For example, card readers we use, right, to punch in our credentials, to read our credentials, right? We have locking systems, we have locking mechanism, the locks, we have electromagnetic mag locks, okay, we have electrical strike locks, we have electrical edge attractions lock, and we have pneumatic locks, we have electrified motors lock. So varieties kind of doors are in the market. We use it according to the building codes, we according to it our needs, so there are multiple types of locking mechanism, right? Then we have egress and override buttons. For example, we have door releases buttons to push and open the door, or maybe we have EXB, some kind of, we do have an push button called EXB, which is called emergency exit button, right? So Okay, so sorry about this. There are some dogs are barking over them over outside my house, so please forgive me, friends. So we have various kind of buttons also, right? Push buttons, right? Door release buttons. Often you will notice like that is a very small kind of a box, and then a small, a push type of button inside it. I will show you. Door release. ACS. So one thing, friends, if you are watching till the if you are watching the video, please make sure you subscribe the channel. It will really helpful for me. It will motivate me to make multiple videos in future, right? Also, the videos I will again tell you again, the video is going to be little bit longer, friends. But I make sure this video is uh, look, the ACS system is a very large system, right? It can be covered in a 1 to 2 hours or maybe a five. I don't believe in like it's a very vast topic of engineering. But I will try in this video maximum. I will try like you have an overall idea how the system works, what are the main blocks which power the system generally. Okay. So I believe you often might see this kind of arrangement, like beside doors and offices, maybe some metro station, maybe offices, mostly offices, right? So this is an emergency door release in case of emergency fire breakout in the building, maybe. So by breaking this glass or by push this button, you can escape from that building to secure more secure place. Then we have door monitoring sensors. These are called DS door switches. Somewhere we called it door status switches. These are called door sensors also. So they sense the whether the door is locked or not, the door is forcefully closed or forcefully opened or not. So these are the devices. And apart from this, we often have some buzzer also above the doors, right? We have some buzzers also to if someone intrudes or maybe someone is tailgating. Okay, so we can by the buzzer will be sound. The buzzer will make a sound. So I will try to show you some kind of buzzer above door. I believe there should be I'm not finding any, not finding any actual buzzer. Maybe this one. This one. Generally, these buzzers are placed at the top of the door or maybe a side of the door at almost 2 meters of the height. Okay, maybe 2.5 meter height. So these are the devices. Some of the devices I have mentioned here. Next, some protocols we will, we follow. By following this protocol, the standards, the overall connection is made, the overall system is function, right? So these are some standards. For example, they are very common, and in today's generation, this Ethernet, TCP/IP, right? Transmission Control Protocol, I believe, and IP Internet Protocol. These two protocols are widely used. These are the two most advanced till the date. Uh, but there is a limitation in this, standard, which is 90 meter. The first controller from the server, from the rack, it should be within 90 meter. And for, safer purpose, we always, um, match the 90 meter, right? We always try to limit our distance before 90 meters, for example, best from 70 to 80 meters, for example, right? So that will be a safer side we follow. But apart from that part, we use Ethernet. This Ethernet TCP IP protocol is widely used. Here we use generally RJ45 ports, Cat6a cables, and some controllers, some ACS controllers also supports PoE or maybe run also on if it's a little bit heavier equipment, like it draws little bit higher side of needs a higher side of power. So maybe PoE plus or maybe PoE double plus is sufficient. So TCP/IP is a very important, very useful and widely using right now in for access control system protocols. Secondly, we have of course fiber optic cables. If for example, if our cabinet, the security cabinet where the all we all connect the controllers, the access level, access level, or maybe the distribution level server is in the far place. For example, it's in the main control building, right? Main security building, or maybe a main control center, whatever, according to the project, right? But our application door is a little bit longer, maybe on far from like 200 meters from that main control room. So what we do, we can use a multi-mode, or we can use a fiber optic cable to you know reach that application area. Later that we can convert it into Ethernet. Okay, Cat 6 or maybe Cat 6A cables. We can then connect it by maybe a media converter, for example, right? So and lastly, we have another protocol called RS485. This is a serial protocol, and this is a kind of older, mm, version of protocols used in access control system. But I believe I believe this is still using we still use this protocol because of its range. It goes almost 1 kilometer, 1,200 meters. Its range is, that's why we still use this protocol, and it replaced the more older protocols like Wignan protocols, but this RS485, it still is older than TCP/IP fiber optics, Ethernet, but it's still we use in today's projects. And the fourth we will try to learn is we follow why we keep this in mind, the code compliances, right? The regulatory code, I believe the sound is still working, right? Mm, yes, everything is fine. So, let me drink a water. So, code requirements often is differ from country to country, from maybe from state to state, right? And we keep in mind that our design follows all the codes which are defined by the code maker organizations, right? We shouldn't violate any codes, right? We first we need to check, we should design, and we have to make our design that follows the code. For example, okay guys, so I'm not reading line by line this PDF cause I am telling you whatever I did in my little career, and especially in my last project, right? But this all points are, of course, these all points I am describing are followed in the industry, right? But I'm not, reading that line by line. I'm telling you by my own concept, my own engineering knowledge. So, for example, there is NBC, National Building Code in India. Also, there is an International Building Code, NFPA 101, right? Uh, for example, if I give you an example, if we are making a building in India, okay, so if that building, there is a room in that building, okay, that building is we are making by following the NBC, National Building Code, right? So there is a room in that building, and if we have two doors in that room, one room can have one door can have access control system without any crash bar, panic bar on the inside side of the building, only access control, right? Another door can have uh, a only emergency door, a crash bar, right? This is NBC suggest. Okay. But if you check a building which is mostly semiconductor facilities and modern data centers, right? That building is building and constructing by following the IBC strictly, defines that each and every doors in the hazardous areas should consist each and every door should consist a crash bar inside. So people, if in case of emergency, people can came through the egress path and they can push that crash bar, push that push bar, or maybe panic bar, and they can, uh, you know, uh, go go outside that room. They can escape, right? So this is how systems work. The code compliance, different code requirements works. Also, there is some zone compliances. Also, for example, ATEX, hazardous zone compliances. For example, if we are giving access control to a much more, you know, hazardous place, for example a chemical factory, for example a chemical warehouse where PGMEA and acid, sulfuric acid, such like chemicals are there, flammable gas are maybe there. So we should, first of all, the outside by the way, by the outside, the devices coming in the outside, for example a card reader is placed in the outside of the side of the door, should be weatherproof, right? But if the place is hazardous, we need to place ATEX certified devices so that in case of explosion, in case of any kind of emergency, the if the area blast or something, our system should be robust enough to handle that kind of situation. You can see like applicable in clean rooms, chemical plants, oil and gas, or battery rooms, class division 1 or 2, right? Requires intrinsically, uh, intrinsically safe field devices, explosion-proof reader enclosures, and galvanic isolation barriers, right? So just what I told you, we need to follow that also. We need to check that also. Next, we will see like the mock-up test are there, like we have now came like a long way, right? And we have an overall idea about how our design will look, how our design is ready, and how our system will look like, and how our system will be working. But before to install it on every door, right, we need to check that also by a test, and we call it a mock-up test. Like before mass site deployment, a physical mock-up test bench is created to validate uh, uh, hardware interoperability, hard English, timing logic, and life safety, fail-safe releases. Like everything is working, by the order or not, by our design, or everything is fine or not. So we do this kind of test also on the site, right? Next, if I scroll the PDF, like the yeah, so fire alarm integration and interfacing, of course. For example, there will be uh, other systems also, right? For example, fire alarm system, for example, public address systems, for example, CCTV systems. So there are multiple ELV services in that building also. So we need to, interface with, so that in case of fire alarm, the our door can release. So for that, of course we have control modules there, we have monitor modules there to monitor, like for a fire alarm system, there is monitor module is monitoring the you know situation, overall situation. And for we have control modules for controlling other circuits, right? For example, access control, uh, maybe public address, right? And by to make this happen, we use for the interfacing, we have fire alarm system relay modules, we have hardware interlocks, and we have controller responses. So for the fire alarm delay modules, we have so what is written here? Fire alarm systems provides dedicated normally closed NC or normally open, potential free dry contacts also to the ACS controllers. So according to the this kind of relay modules or dry contacts, our controller can get that signal from the fire alarm system, and it can by switching the power, turn on and off, our door can be closed and open in case of egress and emergency, right? So there are some 2 points also, but you can read this by pausing that video. I will jump to the next point, which is SCR room architecture, server and control room 7. So this is the main building, guys, right? This is the this is the last point our, and let me check it's still working or not. Yeah, we are fine. So ACR room, this is the main control room. In some cases, in some projects, this room can be defined as some other name also. That is that is not standardization that SCR room have to be there. So SCR room architecture, for example, there will be a primary main in that room, in that building. There will be a primary ACS server. Often this is include as a common server for access control and CCTV, right? They are sharing mostly. They are sharing the servers, or could be possible that ACS server as standalone and CCTV server is standalone. Both are different together, but in our case, primary access server will be there, ACS server will be there, then there will be a secondary standby server, then there will be a client workstation, or HMI, means human machine interface. So this is the very typical generalized block diagram, but in actual field, in actual projects, these are very um, long drafted block diagrams and one-line diagrams are there generally, which like we start from the main control room, and then everything is there in the one-line diagrams, right? From how the connections will go from primary to secondary server, whether the primary servers will be one or two, maybe redundant for redundancy. There in some cases we lay two parallel, FO cables, fiber optic cables for redundancy. We often follows ring communication, ring connectivity for redundancy. So there is much, like, this is a very broader part, I believe, and so this is how the system actually works. Okay, uh, so there are ACS controllers. For example, the firstly there will be the primary, the core switches in the primary access server. Then there will be secondary standby access server. Then there will be these two will be the distribution level, right? Then there will be access level switches, access level servers. Then there will be, first there will be core servers, then will be distribution servers, then there will be access servers, then there will be our controllers, access controllers, which will be ending up in the controlling the doors. So before controlling the door, the from that cables from that controller will be go to the, first there will be junction box at above the door. Then branching conduits will be go to the each and every devices in the door. So these are very complex things, right? But I believe if you have any kind of doubt, you can ask me in the comment, and I am trying to, make this channel content. I know there is a pause for a like quite a while. I haven't posted any videos, but I will try whenever I will try in future, near future, to upload some engineering, to to push this channel towards engineering more and more, to have an idea about this technical things. These are the main things we need to learn. BIM is a tool, right? BIM is a tool. BIM is a software tools that we use, but we need to, I believe we need to learn more and more our technical engineering, whatever we learned in our bachelor and our masters of engineering, right? So if you love this video, give it a thumbs up, and make sure to subscribe my channel. You can follow me on my Instagram. Sorry, you can follow me on my LinkedIn. I would suggest to. I am more active in LinkedIn, and just doubt your comments. And if you have any idea that if you want to see in tutorials in another topic of electrical engineering, you can comment. Thank you so much, guys. This is Amrit Kumar Tripathi, electrical designer. So let's see you guys in the next video. Thank you so much for being till to stay in this video till the last. Bye. Thank you.